with cosmic pi trigger slabs that you can see right there. So the signal from the scintillators is sent to a little amplifier board, which is this one, a lovely board from Advanced. And you have two outputs, one which is a high gain output, this output here, and another which is a lower gain output. And so the high gain output goes to the trigger board, which is this board here. And the low gain output we just use for monitoring. We can send a signal to the scope. Now, what we do here is connect the power to the board, and this little lead connects the power to the MPPC, which is the photosensor. That's done. Okay, so now we have a slab like this on the front of the detector and another at the rear. Okay, so in principle, we power a few things, so the boards need power. Okay, so this little power supply powers the 5 boards, the trigger board and the 4 amplifier boards with plus minus 5 volts. And then this power supply here powers the photosensors, and they need slightly higher voltage, 67.5. It depends a little bit on the type of photosensor. So now we're ready to get the scope and see if we see any signal. To find the right cable, so it's a bit of a spaghetti mess. Spaghetti of cables. That's one. This is the LED driver. Okay. So we have connectors front and rear. We should have a monitor. Trigger 1 monitor. Hang on a second. We have then, what I would like to show is just the coincidence from 2 outputs of the same scintillator. And so for this, with this little board here, let me just power it off again, you have a jumper, so you can actually disable the rear channels, which are here. And so they are, in principle, already disabled. Yes, that's disabled. And that is enabled, actually. They're all enabled. So disable, disable, leaving just the front scintillator slab enabled, right? So what we've done here is we've taken the outputs and the 2 photosensors connected to that front slab. We've connected it to the trigger board, and we have disabled the rear slab so that the trigger board is only reacting to the 2 outputs from the single slab. Okay, and so what we have here on the screen is the 2 photosensor outputs and the trigger pulse, which is created. Now, just a word on the trigger levels that we set. The trigger levels were tuned, actually, so you have small potentiometers here that allow you to trim the threshold. And in this particular case, we selected a threshold of minus 400 millivolts. It's a negative going signal. And that corresponds to roughly 7-8 photoelectrons. So we know from measuring this slab beforehand that 45 millivolts corresponds to 1 photoelectron. So by setting a threshold which is high enough, 400 millivolts, 8-9 photoelectrons, we are sure that we are very unlikely to be triggering on the noise of the photosensor. Very, very unlikely. And this is basically what can be seen here.
Great, thank you.
Okay.